All right, still in section 1-2, we're on page 11, starting with scientific notation. So this is a concept you may or may not have heard of before, but here's the basic concept. Scientific notation is a way to write really, really big numbers or really, really small numbers in an easier way. So here's the deal. The first number in scientific notation must be between 1 and 10. So 1.2 works. The second part, so then it's going to be times 10 to a power. So it's always going to be a base of a 10 and the exponent. If you have a big number, your exponent is going to be positive. So positive is big. I always think money, right? If I got a lot of money, that's a positive thing. If your exponent is negative, you're dealing with a very, very small number. And when I say small, I mean less than 1. So you're going to have a little decimal for that first number. All right, so let's go through a couple of these here on page 11. So number 1, U.S. population is 316 million. Well, first you've got to write that number in standard form. So 316 million. How many zeros is million? 6. So I'm going to add 6 decimal places. And because there's no decimal, it's automatically after the 6. There's 4, 5, 6. Now this is a number I want to put in scientific notation. So our first number needs to be between 1 and 10. Well, if I'm looking at this, I'm going to need my decimal point to be right here. So I have 3.16. And this is kind of where the significant digits come in, because with that first part of your scientific notation, you only want the significant digits. So it's everything that's not 0, right? If there's a 0 in the middle, sorry, you'll have that. Okay, so 3.16 times 10. Now, is this a big number or a small number? Well, if I had $316 million, I would be pretty happy. So we're going to have a positive number. Now, what is your exponent? How many places did you move your decimal? So right now in 316 million, we don't have a decimal, so it's automatically at the end. So how many places did I move it to get to that red arrow? 1, 2, 3, 4, 5, 6, 7, 8. So my exponent is going to be an 8. Number 2 is very similar. We've got world population is nearing 7.2 billion. Okay, so we're at 7.2. Now, billion is 9 decimal places, but notice that I have this 0.2. So I'm going to change this to a comma and then add 9. The 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9. So notice that billion is 9, but because we had a number after a decimal, we only needed 9 places, not necessarily 9 zeros. So my first number, here my decimal, so I'd have 7.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And sometimes if they give you like a 7.2 billion, you can kind of do a shortcut and say it's already 7.2 is already between 1 and 10. Billion means 9, so there's your 10 to the 9th. All right. 3 and 4, I'm going to let you do it on your own. Let's go to 5 and 6. 5, convert 6.789 times 10 to the 5th. So let's write that down. 6.789 times 10 to the 5th to standard notation. All right, now notice the 5 is positive. That means our number's going to get bigger. And I'm going to move it 5 places. It's got to get bigger, so it's got to go to the right. So I'm going to go 1, 2, 3, 4, 5. Well, notice I have these 2 empty humps, or whatever you want to call them, and those get filled in with zeros. So when I go to write my answer, I have 6,789 and then 2 new zeros. So my answer in standard form is 678,900. For number 6, we have a similar 3.45678. We have some very creative examples here. Now we are to the 3rd power, so we're moving 3 places, getting bigger. So 1, 2, 3. I've got 3,456 and 7/800ths. That's a decimal point there in standard form. So that takes care of that. Let's go on to page 12 for product rules. All right, exponential rules. When you're looking at product, right? Product means multiply. And so you're going to need to remember that when you multiply and the base is the same. So notice how these both have bases of A. Your base stays the same, but you add the exponents. So multiplication and addition go together, and division. Quotient is division. So if you're dividing, again, notice same base, then we subtract our exponents with the top exponent always coming first. So, in number 7, 2.7 times 10 to the 4th times 3.2 times 10 to the 5th. Well, I'm going to take 2.7 times 10 to the 4th times, whoa, what happened? Times 3.2 times 10 to the 5th. So I'm going to put these numbers together. Well, what is 2.7 times 3.2? Well, let me get my calculator. And it's 8.64. Okay, times 10 to the, well, if I have 10 to the 4th times 10 to the 5th, base stays the same. I'm going to add 4 plus 5 is 9. So after you multiply, you have to decide, am I in scientific notation? And in this case, yes, because that first number, 8.64, is between 1 and 10, so you're golden. I'm going to go ahead and let you put that in standard notation, right? Exponent of 9, so you're going to move this decimal 9 places to the right. And number 8, we're dividing. So 8.4 times 10 to the 9th all over 2.1 times 10 to the 5th. Well, first let's divide that that first part. 8.4 divided by 2.1 just gives us 4, nice and easy. Times 10 to the, right, base stays the same and we subtract. Start with the top. 9 minus 5 gives me an exponent of 4. So 4 times 10 to the 4th, and again, I'll let you do the standard notation. Okay. All right, I'm going to ask that you work pages 13 through 15 on your own. 13 is more work with scientific notation, adding, or multiplying and dividing. And then 14 and 15 are really kind of reviews on equivalent forms of numbers, reducing fractions, that kind of thing, getting you ready to deal with ratios in section 3. So check those out. If you have questions on those pages, let me know, and I can do extra videos. But in terms of this lesson, I think those, that kind of covers the majority of what we're going to do. So, thanks.